I offered to do this talk, I think, before Christmas. I've been preparing for it for a long, long time. And it's the purpose of this talk is to show you ways of writing code to automatically test bits of Obsidian plugins. But actually, it's more general than that. It doesn't have to be specific to plugins. It doesn't have to be specific to Obsidian. The examples are written in the TypeScript language because that's the main language of Obsidian plugins, but the principles are way more general than that. And all the techniques I'm talking about today, we use working on the Python code in the Obsidian Community Hub, for example. So I hope that sort of context lets you know that I try not to think of it as purely about Obsidian. It's just the examples are chosen for Obsidian plugin developers. So find broken things before your users do. Here's my Twitter handle at the bottom, and I'm also on OMG Discord as well. I'm very happy to answer questions during the talk if you want to pipe up, and afterwards as well. So let's move on. So just briefly about me, I, by trade and by training, I'm a scientific software engineer. Back at the beginning of 2019, I gave a talk on testing legacy C++ code, so testing untested C++ code. And I enjoyed that so much that I started volunteering to give talks at local groups. And by the middle of 2019, I'd actually left my job of 30 years because I was enjoying so much learning about testing and giving talks at conferences. And of course, traveling to conferences was a big part of it. That I switched from being a full-time programmer to part-time open source contributor and conference speaker, and I kept that up. This is just a small snapshot of my talks. I spoke on testing legacy code and on refactoring code as well, and that was going really, really well, and the traveling was going great till the pandemic hit, and then I stuck about a year's worth of Zoom talks. And then that was just getting really old. So I stepped back from all of that and decided to port my 10 or so years of Markdown documents away from editorial on the iPad and towards Obsidian. And thus began a whole new phase of my life. And well, here we are now. So this is my first talk since retiring from public speaking. So I struggled. I have spent several days writing slides, planning what to say, figuring out the important points, learning how to write slides in Obsidian as well. And the more I looked at it, it was just too dry. It was long lists of do this, don't do that. And I'm really conscious this is a different audience. So previously I was speaking to predominantly professional software engineers. A professional as in they earn their living from software development, and their job probably included time to write tests, and there was a sort of certain expectation of quality in a lot of cases, and that just didn't feel like it was quite the right style, and it felt like it was missing some of the motivation. So this morning I threw all of that away and planned some demonstrations instead to show you existing code. And I'll be making much the same points, but I got some lovely advice when I first started doing public conference talks about show, don't tell. So a lot of this, rather than describing things that I'm recommending that you do, I'm actually going to demonstrate it and then try and pick out the key points for you. So I'm going to start with a plugin called Note Refactor. Now, I'm going through 4 plugins. I'm going to do Note Refactor, Dataview, Linked Data Helper, and the Tasks plugin. So a variety of different plugins. And we'll do a little bit of modifying code along the way, but a lot of it is actually just explaining how the tests work. So this one, it actually happens to be written in a test framework called Mocha. And this will be the only plugin that I show you that uses Mocha. So a general thing to say is Most of the demos I do will be using Jest because I found that is easier to use than Mocha. But I wanted to show you a Mocha test so that you see that, well, how you write the tests will vary slightly, but the principles of writing the tests will be the same. So let's look at a simple test here. So this is got some imports. Are you seeing my screen okay? I've just had a bizarre Zoom message pop up. I'll assume that people will jump up and down if there's a problem with the screen sharing. So yeah, a test generally consists of a text description that's trying to describe what the purpose of the test is, and then some code that is called. So this is actually, I guess it's accessing a property. So we've got a settings object that's been created. We're saying what is the new file location property on that settings object, and it should equal location.vault folder. So I'm going to assume, because the things on the right are generally static things, that the second argument is what the correct answer is. That's the expected answer. And then the parameter on the left is the thing that we're testing. So this particular, it's called settings.test.ts, and it's testing the default values of the settings. So that would guard against some code accidentally changing the default behavior of the settings, which obviously could affect users. If they don't have a settings file, then if the default behavior changed, they get a change in behavior of the plugin. So it's not a huge volume of code. The sorts of things it's testing text manipulation. It's got nice descriptions of what it's doing. And that's the sort of testing that I'm talking about in this talk. So there's another kind of testing, which is manual testing, which is you edit your source code, something compiles it into a plugin, and probably you've got hot reload in your test vault, and your plugin will get updated, and then you'll manually go through some testing. But this is, and each time you change the code, you have to decide how much more manual testing to do. This is a different thing. This is capturing the description of the intended behavior inside a body of test code. Spoiler, it can be a little bit hard to get going. Spoiler number 2, when you get proficient at it, you'll save yourself huge amounts of time. You'll help people contribute to your project, and you'll make far fewer mistakes. But it is a skill that takes time to learn. It's not like, here's this magic stuff, you can immediately be more productive. This is the sorts of things you can do, and this is the value of it. That's a little bit of a taster of the Note Refactor plugin. So there's some things that the test files generally correspond in name to the source files. So that can be quite helpful in terms of understanding the test coverage. Can't immediately see it, but it shows somewhere in here how to set up. Oh, here we go, mocks. That's what we've got. So it's able to pretend when the test is running that the calendar date is a particular date in the calendar. So that's a really useful skill to have and to know about. So that's an example of how it's done in Mocha. So if I switch back to the slides, so that's a link to Note Refactor and a few summaries of it. Oh, it has a sample data file, a sample markdown file in the tests as well, which is a nice thing to do. So you don't have to generate all your data in code. You can actually read files in the tests. So the next one I'm going to go to is Dataview, which I think is a very well-known plugin. So you can run queries on notes in your whole vault, generate tables and lists, different ways of representing summaries of data. in your vault. Now, this one is written using a test framework called Jest. Now, bear in mind that I said I'm a C++ developer, so I can't speak with any authority about which test framework is better than which other, and I can't give you a complete list in TypeScript or JavaScript. But I can say I've seen many more people use Jest than Mocha in the Obsidian plugin community. I've seen lots of articles online that say that Jest is easier to set up. And in my experience of pairing with a few different plugin developers, Jest is massively better documented for setup, massively better contained, and much richer functionality out of the box. I guess overall, I would say pick a framework and get to know it. So if you already know a different framework, then stick with that. But this one is using Jest. And I want to show you in... So I'm using WebStorm, which is a JetBrains tool for JavaScript type languages. Again, I'm not saying thou shalt use this particular tool. It happens to be that I use the JetBrains tools across lots of different languages. And so their shortcuts are in their muscle memory. I understand how to do lots of different things. I just know the names of the menu options and things like that. So again, pick an IDE and become proficient with it. But I want to show you, I'm going to get rid of those experiments from my previous running. So when you first open a new project, you're going to want to understand how to run its tests. And often it will be documented in a README, or a contributing file. But the thing I like to do is to look at the GitHub workflows and see if we have any instructions for how to build and test the project. And so here we can see that we're building the project on Ubuntu, and it's setting up Node and then doing npm install, npm run build. And then it's got another job, which is the test, and it's doing npm run test. So I can go to my terminal and I can just run that. And this is by far the largest test suite that I'm going to run. And when it's run from the console, it takes about 13 seconds. And when you're making lots of small changes and running the tests each time, that is a long time. Okay, its guess was pretty good. If we get any test failures, we would get information in the console. And I find that it helps my productivity if I can actually run tests within my development environment. So for those of you using JetBrains tools, I just wanted to show you how to do that. So I clicked on Add Configuration, and it's a Jest project. And so I click on Apply, and now it's got a configuration to run all of the tests. Now I can just click Run. And maybe it saves a bit of time running them in parallel, I don't know. But still this feels slow. But if I was developing this project, starting to contribute to this, it would give me a lot of confidence that I could test and say for the area that I'm working in, what tests are there. But I also want to point out that if I navigate to a test, so let's pick the utilities ones, for example. Let's go for normalize. There's other ways to run tests. So I can right click on a file. That is interesting. I really expected that would have a run button. And I've gone through this about 6 times today, and it's had a run button every time. Okay, well, that is unfortunate and really rather confusing. So what I would wait a minute, it's because I'm not in a test. It is smarter than me. So where are the tests? They must be in a subdirectory, right? Test utils. Okay, normalize. So now I can right click. It has a color coding, so green for test files. So I think a relatively recent thing in the JetBrains tool. So I can run the entire test. So you can see what Jest tests look like. So we've got a test function. We're saying, so the expect, what's inside expect is the thing that we're calling, the thing that we are executing. And then this way it's written in Jest is expect that to equal, and then a clear string for the stated result. So that's my test running. So you can imagine if I was working on this area for any length of time, I would run just those tests to speed up my turnaround time. But what I've done is I have intentionally saved a change that breaks the code just to show you what it looks like. Is that a question? Okay. So this is what it looks like in the JetBrains tools. And so we get the really nice highlighting of what was the received versus what was the expected. So the expected is the right answer. It shows us the two different strings, and I can even click to see a difference between the two. And I've changed it so that it's giving me the most granular difference, showing individual characters. So that's really lovely. And you can do things like rerun only the failing tests and things like that. So it's a great way to explore code. And the fact that I can immediately click on a test and I can say, debug just this particular failing test. That sort of granularity of running tests is really, really powerful. So let's go back. So Dataview uses Jest. Its test coverage is really good. It's doing, depending on what the code is doing, lots of tests can add up to slower runtime, or you can also get lots of tests that run really, really fast. So that's probably enough about that. So let's move on to linked data helper. So this is by Koala, as is known in Discord. And Koala and I paired, I think before Christmas, for a few sessions to explore adding tests to this plugin. So this plugin, when it's run for real, it downloads huge amounts of data and processes them and converts them into a form that another plugin, linked data vocabularies, can process. So users would generally, as I understand it, run linked data helper once, set up the data, and then linked data vocabulary many times when they're using that plugin. So that was quite slow to test because I forget, but downloading several gigabytes of data. And you can test it by hand, but it's not a great turnaround time. And also the data changes over time. So we went through a few different iterations, and what we ended up doing, okay, so here is the test file. I'm going to go down to the first test. So the first test we wrote is a very simple Jest expect. So read a file. So here you can see that we've got a file called history.json in the repo, and it's, you know, it's a sizable chunk of data, 500 lines or something. And so it's reading the file, it's getting out of the results from that function a context bucket of data, and then saying get the about value from that and testing it equals an expected value. And when you think about the length of that file that I just showed you, the thought of writing explicit expect tests, you just don't get good coverage like that. It's just too time consuming. So there's an alternative approach to testing, which Jest calls snapshot testing. And so and other names for snapshot testing are approval tests, characterization tests. They used to be called golden master tests, but that's a less descriptive name. So people generally try and use characterization, snapshot, or approval tests or approval testing instead. Jest calls it snapshot tests. And what happens is you get some data, you get an object, you get a container, and well, here we've got a helper function. So let's go into match.snapshot. Okay, so we're passing in these three things, and we're saying expect.thing1, and rather than saying expect it to equal a string or a value or an array, we're saying expect it to match a snapshot. And the first time we run this test, Jest creates a snapshot file with a name that matches our source file. So we've got lock.test.ts, and then we've got the same file name with .snap. And what it's done is it's written out the data that was in the objects that have been saved as a snapshot in a readable form. And so this sort of thing, it can be useful just to understand code and the objects in the code that you're learning about by saving a snapshot of the data of the variables, whatever the fields, and investigating what's there. But let's see what happens if we make this test fail. So I'm going to break the snapshot tests again. So I've done this by breaking the input data. So I've just changed on the left-hand side, data was tough, which I'm sure is the right answer, but I've changed it to stuff just to see what happens. So let's run these tests, and no, it's running it in the console, but that's fine. So this is a different sort of output. So I think this was before I understood how to create a Jest, run Jest directly in the IDE. So it says the snapshot of JSON parsing logic failed, and another test failed as well. But let's look at the snapshot. So it's telling me which snapshot failed. It's saying that the what's in this sort of pinky color is the snapshot. So that was the saved output. And then what's in cyan color is the received. So that's the output from the current run. And you can see it's just showing the differences. And it's telling me where the failure was. So that can be a really powerful way. Snapshot testing can be a really powerful way of testing things that are either hard to create or that would take too many expects or asserts or whatever to test them. And normally at this point in a talk, I would be telling you about the Node implementation of the approval tests testing framework, testing approach. So how I got into speaking about testing was I became the co-author of the C++ implementation of approval tests. And approval tests does basically the same kind of thing, but the output files are a lot more manageable. And when you get a failure, it pops up a differencing tool, and you can actually manually select which bits that you want to preserve from the new behavior. So usability wise, it's a lot better than Jest in terms of writing these kinds of tests or running these kinds of tests. But the JavaScript and TypeScript implementation of approval tests only works with Mocha and not with Jest. And Skeptic Mystic and I had multiple pairing sessions trying to get that working and working well. And with my level of knowledge at the time, I don't think it's fair to say we really succeeded at all. So I've since seen recommendations that if you're starting with testing, the snapshot testing in Jest is a lot easier to get going with, and that certainly matches with our expectation, with our experience. So back to the slides. So yeah, test data stored in the repo, uses Jest snapshots, and there's a lovely quote at the end of it. So I have to say, it's really a good feeling. I can just run the tests and see that I get the same output instead of needing to run the commands inside Obsidian. That was a proud moment for me. So right, on to the last plugin to show you, and this is Obsidian Tasks. And part of me, so I didn't just move my markdown files from the editorial iPad app to Obsidian. I also moved an embarrassingly large number of tasks from some online web system that was just so unreliable. And I'd gone through about 3 or 4 of those in the last few years. And eventually I decided to try and get all of that data into Obsidian as well. As a result of which I've got to know the Tasks plugin as a user quite well, but also ended up contributing some functionality, much of which isn't merged yet, that I've been quite desperate to have. So I've been running the tests here quite a lot. So far, I've shown you individual tests, and I have shown you tests that are based on files, but this has got some nice alternatives that I'll come to in a minute. I want to show you a couple of things though that are in this repository that you might want to steal as ideas for your own. One is this pre-commit and pre-push mechanism. I assume that left hook is, I haven't Googled it, but I've certainly experienced when I'm developing in this repository. If I go to commit something and the tests don't pass for the changes that I have been making, then it will refuse to commit. Or if I haven't got the formatting right, it will also refuse to commit. And that's on the files I'm editing. If I've made a change to one file and unintentionally broken some other file in the repository, then when I go to push, it runs all of the tests and all of the linting, and I'm actually building the plugin as well on all of the code. And multiple times, both of those have enabled me to discover immediately, almost immediately, that I've forgotten to update something, or an experiment where I made a test fail intentionally to see what happened, to understand the code. Then this told me. So that's really good. Another thing to do again is to look at the GitHub actions. So it's got it's using Yarn rather than Node, so different command line tools, but the same basic idea. So I think a lot of this talk is talking about writing tests to execute your code, and it's talking about the value of that. But with tools like linting tools, you actually get a lot of value for even less effort, particularly because it's not a compiled language. You know, as a C++ developer, if I get something wrong, I expect to be told this doesn't compile, the code is wrong, but you have to run a linting tool or actually execute the code to find that out in a lot of languages. So building that into your process, even if you don't write any tests, is still a really valuable thing to do. Okay, so I'm going to show you, I don't actually know the vocabulary in Jest, but I'm going to show you what I call parameterized tests. So I'm using the JetBrains tool of double tap the shift key to search everywhere. So we're going to look at task.tests.ts and just quickly spin through to show you the kind of idea. So the point about this is that we're separating the data that feeds into the tests from the code that's being executed. And as you'll see, a consequence of this is the actual test code is slightly more complicated, but you then get the ability to add new tests really, really quickly. and your test codes, the actual implementation stays the same. So in Jest, the way that you do that is you write some type, some bucket of storage, and you say what things can be stored in it. And this one, it requires there to be a string value for the interval. This is testing recurring tasks, so it's the recurring interval. And then in this case, everything else is optional with the question mark there. And then we build an array of those objects. So this is saying if the recurrence interval is every 7 days, then if a task was marked to be due, it needed to be done on the 21st of February, then when it's marked as done, the next due date should be the 28th of February, 7 days later. So let's scroll down. And if we were to look at if we were to annotate this and see when tests were added, we would see as new features were added, new tests were added. And I'm sure as bugs were fixed, new tests were added as well. Now, some of them, I will say, if you've got a failure here and you're trying to work out what the problem was, probably it matters whether one of these days is a Monday, Wednesday, or Friday. But you can't immediately tell from that by looking at the test. So that I'm really, really nitpicking now on the basis of experience. This is a really good test, but I would like to see something that explained why that data was chosen and why this is the right answer. And I'll show you how to do that in a minute. Okay, so let's scroll past all of those examples. And now this is our actual test code. And instead of calling test, which you might, and then so now we've got test.each, and the .concurrent means that these can run in parallel. So that would speed up running. So each of the values from that bucket of data is passed in. So this test function is called for each of those sets of data. It sets up a fake date for some of them. For some of them, the date when the test was completed affects the result. So it's really important to know that you can do that. And then it creates some data. So this is inputs to our test. And not to go through the details of this, but if you kind of remember the shape of that code, you'll see it again in a minute, that sort of thing. And so that's all the setup. And then it toggles the task that was just created, which, since it's a not completed task, toggling puts an X on it. And it happens to be that this code returns 2 tests in that case, 2 tasks, because these are recurring ones. So it's looking at the contents of the first of the returned. You don't have to, the details of that don't matter. And then it's got some expect statements. So it's checking that if there's a next due date, it matches. If there's a next scheduled date, it matches what's expected, and so on. So I wanted to show you these kind of parameterized or data-driven tests. They're really, really valuable. And it's worth getting to know your test framework and knowing how to do that. Now I want to show you a different implementation of the same kind of thing. So I recently contributed these tests to the tasks plugin. And they're basically a shameless copy of what I just shown you with very small changes. So the big thing is actually let's run all of the tests so I can show you the behavior. So we were just looking at test of tasks, and it was a toggle done. And what we get is it recurs correctly and we see the data. But there's nothing, so if one of these fails, you have to work out the intention of the test or look at its history. So with the happens one I added an extra thing, an extra field, which is the description. And my intention was that if one of these is broken, then it's saying, okay, you have to know that there's the three options for this happens after, before, or on a particular date. But if you were using the before option, then the task should match if its date is before the specified date, but it should not match the filter if the date is after. And the interesting thing, the boundary case, it should also not match if the start date on the task was the same as the date given by happens if you chose the before option. So that's the thing I haven't really spoken about so far, which is part of the experience that you get from testing, is learning what boundary cases are worth testing. So you don't want to write hundreds of tests just for the sake of it. Each new test should add some new value, should add some new scenario or some new possible cause of error. And so the way I did that was adding a mandatory field description to my case. But I'm not even, when I go to where this is being used, there isn't a description parameter here. It adds no value to the behavior of the test. It adds information to the output if there's a test failure. So there's a general mantra that I really like in testing, which is never trust a test until you've seen it fail. And there's two reasons for that. Oh, there's multiple reasons for that. One thing is you could have just been running one particular test and then you started working on a different test, but you forgot to change the specification of what test you were running. So you thought the test passed that you've just written, but it was a different test that passed. So maybe you're running the wrong test. Maybe you didn't understand the behavior and you thought you'd found a way to reproduce the bug and that your test case was going to fail and then you were going to fix the bug, or you fixed the bug, you ran the test and it passed. Woohoo, you fixed the bug, but actually your test didn't trigger the bug because you didn't understand the bug well enough. So that's another reason. Another reason is when a test fails, you want to know that it generates meaningful output and you or somebody else is going to be able to understand how to fix the test. Well, it's really easy to write tests that say failed, true is not equal to false, which is really not helpful at all. And the only way you can understand that is to go to the source code. And maybe it says test that this string contains the word something or other. And what would be really useful is for the test to write out the something or other it was searching for and the actual string result that was being tested. And so by seeing the test fail before you make it pass, you can satisfy yourself that when it fails because it's paying for its existence, it's giving you useful feedback, you or someone else is going to be able to understand the output. So I'm very quickly going to do a little bit of a demo here, mindful of the time. So I mentioned to you that there was a shape of code, a pattern of code in the tasks test that we were looking at. And I said that I cribbed the code and modified it for this. And what I'm going to do is show you a technique called refactoring and demonstrate it in the JetBrains IDE to show you the kind of thing that you can do with refactoring and how quickly and effectively you can do it. I want to explain, okay, so first of all, refactoring is improving the design of existing code without changing the behavior. So you might be making it easier to reuse it, you might be making it easier to understand, but you're doing the refactoring so that later on it becomes easier to make the change that you're actually wanting to make to the code. So I've noticed that there's a pattern here that multiple tests in this project have this sort of code. And I want to start reusing it. So I want to make a function out of this. And so the way I do that in the JetBrains tools, there's always a shortcut called Refactor this, a menu item. And its shortcut is Control-T on a Mac. And it always pops up a menu. And it's really lovely because it tells you what things you can do with the code that you've got selected. So I'm going to say extract a method. And it's not yet in my muscle memory to remember that in this language you have to choose the scope. So I'm going to say global, and then I give it a name, and I'm going to say create task. I might call it create markdown task or something. It's creating the text representation. Okay, so let's look at what happened there. So let's look at the differences. So we're getting an error up here for some reason, but I want to show you that it's immediately, so don't worry about the error, I'll fix it in a minute. It's not a real error. So what it's done is it's looked at all of the variables that we used inside the scope that I'd selected. And it said, all right, I need parameters to pass those in. And it's just taken care of that. It's put in the types automatically, which is just brilliant. And then it's updated my call. If there were other instances of that in the same file, it would have said, and would you like me to update these other 4 instances already, which is even better. So the problem here is that the line is too long, and this project is set up with very strict immediate checking. And so there is, I'm doing Alt and Enter, which is a standard JetBrains shortcut for, if it's something it can fix, it will do. So I'm going to quickly spin through and show you some more things. So I am going to extract, so we're creating a task now, a task object, an instance from that line. And we're saying there's all this other data that doesn't matter. It's quite standard. And I can, if I select these lines, then I will get something that returns a task object. Whereas if I also select the next line, because that task is not used anywhere else in the function than to create this list or array or whatever, I'll get something that returns a list. So let's do that. Create task array or something. So it's still only taking one string as the task, but it's easier for later tests if I get an array. And then one more thing. So this pattern appears a lot in the tests. So we had a query object, and we're testing that query, that filter. And so we're getting, creating an output, filtered tasks, and then we're iteratively filtering it. And I really, really want to not have to keep typing that. So let's call that that would say about muscle memory. Let's call it filter tasks. Cool. Okay. Why didn't it like that? Okay, so now it can be a const. So it's taken care of that for me. That's not bad, but it feels to me like the query should come first rather than the tasks. Okay, so let's refactor this, change signature. I actually want the query to come first, refactor. Boom, now it's all of my calls, it's updated. So that gives you a flavor of the kinds of things that you can do. So I said all of that is purely with extracting methods and changing parameter orders. You can do amazing things by extracting variables as well, temporarily, and inlining them afterwards. But I don't have time to show you that. I want to show you one last bit of this though. So we've got these functions now. Oh, these are things like it's saying I don't need this temporary variable, I can inline it. So let's show you that. Inline. And so now it's just got the return statement. I mean, I know that you could type that, but you don't even need to think about typing. You don't need to think about formatting. It's just brilliant. So I don't want these to be in this file. I want them to be somewhere else. I'm going to say, actually, let's put them in test helpers. This file doesn't exist yet, but let's move it. And whilst we're there, we'll move the other functions that we just created. And yeah, let's add them to GitHub as well. Okay, there's something it doesn't like there. What doesn't it like? Okay, so what's it saying? Import type should be used. Okay, so I'll fix that. So I think of this as programming at the level of intent. I know what I want to do to change the code. And I don't need to know the language to do it, because I know that the IDE knows the language far better than I ever will. Now, everything about that was in a test file, because that was an example I knew and I could demo it quickly. But in a lot of cases and with a lot of plugins, what you'll find is that you've got some code which is interacting with the Obsidian IDE. It's changing some text content or generating a list or something like that. And you've got your sort of your algorithm, your business logic in the same file that is the Obsidian code. And you can't do import Obsidian in, or it's very, very hard to say import Obsidian into a test, code running in a test framework. I've got some notes of various ways that people have tried to do that, but they're not well used, they're not well maintained. And so if you've got code that you want to test and it's in an Obsidian related source code, you can do exactly that same kind of refactoring I just showed you. Pull all of the brains of your plugin out to separate functions, move them to separate files, and then test the behavior, the implementation detail of your plugin. And that's a really, really big part of adding tests to Obsidian plugins, is separating your logic away from the Obsidian-specific code. Okay, so that was my last plugin to show you. And with 5 minutes left, I'm going to spin very, very quickly through summaries of what I've just shown you. And again, just to say that the point of this is to try, this was never going to be a lesson in any detail about how to do these things. I want to try and show what's possible, and then later on have a conversation about how do we make it easier. So why do you test manually your plugin? Probably you want to know it does the right thing. You want to know when you've done enough work on it. Probably you don't want to break data in your users' vaults. Why automated tests? To do that more quickly. It genuinely speeds up development. Initially it will slow down development, but as you get more proficient, it will speed up. And I'll say this at the end, but I'll say it now. This is an offer to all of you watching. If you have some code that you would like to write automated tests for in Obsidian plugins and you would like a hand, ping me on Discord. Let's make a time to pair for half an hour and look at your code and help you get going. I really enjoy doing that. I have the time to do it. Whatever test framework you pick, get to know it, stick with it. If you don't already use one, then Jest for TypeScript it's TS Jest for TypeScript is a fantastic, fantastic tool to use. Tests are no good if you don't run them. You can be running them in your console. You can be running them in your IDE, which will allow you to develop, to debug as well, which can really help understand why tests fail. You can run them via version control hooks and of course via GitHub Actions. How you deal with failing tests is really important though. Usually the right answer is not to delete the test. No, occasionally it is, but only very, very rarely. Sometimes a test is just too hard to make stable, and flickering randomly failing tests are worse than no tests. But as as I'm running a test, every time I run a test, as I'm hitting run, what's going through my mind is, what do I expect to happen? Do I expect it to pass? Do I expect it to fail? If it fails, what do I expect? Do I expect a compiler error or linting type error? Incorrect parameters, code doesn't exist. Do I expect a test? If a test, I'm expecting a failure, what type of failure? So that can be really, really helpful. And so many times I expect a test to fail and it passes, or vice versa. And that's really valuable information. If it fails, you need to decide and work out whether it's now a bug or a feature. So if you were not expecting to change the behavior and the test fails, probably what you need to do is look at your uncommitted changes and work out what you didn't understand that accidentally broke the behavior. If you're implementing a new feature, then of course you expect the behavior to change, and typically you'll write a new test or update an existing test if it's a change to existing behavior. Refactoring, which I've demoed right at the end, is a super valuable skill, and it really matters when writing tests, because if at the time the code was written there were not tests, it's very, very likely, firstly, that you won't be able to call the code in isolation because it's embedded in other stuff. It's also very likely that there are bugs lurking in there as well, perhaps for corner cases. So as much as possible, let your development environment do the work. I'm afraid VS Code is more of an editor than a development environment. It has very few refactorings in a few languages, but for JavaScript and TypeScript, there's an amazing extension called Abracadabra Refactor This, which has got brilliant refactorings in it, and I really recommend using it if VS Code is your tool of choice. So what next for you? Well, if I have piqued your interest and you want to try writing a test, then have a go, and ping me if you want to talk about it or if you'd like help. What next for Obsidian plugins and testing of Obsidian plugins in general? The original version of this talk had pages and pages of, this is hard, here's one thing I found a year ago that was written a year ago in some issue or in the forum or whatever. And it's, there's lots of outdated data. There's a few people wrote test frameworks that look like they're really powerful, but they haven't changed in a year. There's a suggestion from Leica that maybe it might be worth writing a general testing framework for Obsidian, but that was, exciting, but a year ago. So I really would like, so what next? Kind of thinking out loud, but I did offer to add something to Marcus's general advice on how to write a plugin. But again, I fell foul of too much stuff, don't know how to structure it, lots of stuff out of date. I thought about suggesting a specific channel in the Discord for perhaps plugin dev testing. That's bit ambiguous. I was thinking of it as being for automated testing, but maybe manual testing as well. Maybe we set up a vault somewhere that's a shared vault. I thought about suggesting it for the hub, but the turnaround time, I feel like it's quite detailed. I don't think it's really a good fit for the hub. So maybe have a different vault somewhere. I don't know. I do know that I've got this huge amount of information in my head and in reams of markdown notes, and I want to get it out of my head and share it with other people. But I also know that me doing it on my own, it's not going to be an effective way of doing it. So I'd love to work with other people to talk about where to do it and how, and to work on it. It would be great to see some way that we have perhaps some central resource, some central library that makes it easier to test Obsidian behavior. It'd be wonderful if there was an official thing that as Obsidian got updated, then the test framework got updated as well, because that's where a lot of developer time is going, is trying to work around. sort of unofficial things changing. So I think I'll stop there, just on the hour, and I guess let's have a look at chats.
Yeah, I can start with some of the questions that
sure.
were mentioned in the chat. Do you know if there is any plugin or if any plugin already tests the interaction with Obsidian itself, or is there a need to mock the Obsidian API?
So somebody tried mocking the API or the file reading part of the API, and that's I'll figure out how to share links later. I'm not going to. It's too time consuming to go through them now. That's in a plugin called Obsidian, but that hasn't been updated for a year. And I could find no real world use of it. Shame, because it's really exciting. Somebody was able to use is CodeMirror the framework behind Obsidian. Somebody documented that they were able to write tests and express them using CodeMirror. So I think they did something like alias Obsidian to CodeMirror or something like that. So that looks like it's probably quite a promising approach.
It's someone in the audience, actually.
Ah, excellent.
Very nice. As for the links and resources, I'm going to create a hub node for the talk itself, so that when we post the video goes there. We mention you so that you get the link to all the stuff you do, and we can also add resources there as well.
Brilliant. That's a big thing ticked off my list, knowing where to put it. Thank you.
Yeah. So next question was, do we have a list of Obsidian plugins that do tests or use tests so that people can use as a reference?
Yes. Yeah, I don't want to share the rest of my screen at the moment to show it, but I spent stupid amounts of time creating a slide that showed you the list of all of the ones that use Jest at the moment. And it's a few dozen, and a lot of them do have really good tests. I guess that's actually the thing I didn't, in case it wasn't obvious, I really think that a great way to learn about testing is to read tests other people have written in that are close to your domain. So in this case, Obsidian plugin developers. I've learned a huge amount by reading other people's code.
Yeah. So now let me ask one question, sort of on behalf of maybe the majority of Obsidian developers that don't have tests, or even people who are maybe new to software development and do not even know how to start with testing. So say you have your repo, you have your plugin that works, or you haven't found maybe as many bugs. Where do you start? How do you identify what is the first thing to write a test for?
Okay. I should have opened my version 1 set of slides. I will okay, let's get out of these. How do I get out of full screen view?
I think ESC should do it.
Yeah.
Or also that. Yeah.
Okay. So for the mechanics, if I go to the JS test site, TS Jest. One of the reasons I think this is such a good test framework to start with is this table here. So with Koala, I think Koala was the first person I paired with who chose to use Jest, and he was already familiar with Yarn, and he just went, or whichever, I forget which it was, Yarn or NPM, bang, 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 done. So that's the test framework set up, and that is really, really valuable that it's so streamlined to do. Then the next thing is the first test, and that's a slide that bit the dust when I switched to demos. But the thing I'll say is however experienced you are in writing tests, and especially if you haven't written tests before, the first test is always hard, because you might be learning to use the test framework, you might be trying to figure out how to call your own code. So my first test in any project is something like assert that 1 equals 2. It might sound trivial, but the fact that you can see that it fails, that you know that you're running it, and you can navigate to the source code is huge. And then the next thing will be, what's the tiniest increment in your project that you can call? And, if you don't have anything that can be called that's separate, write an implementation function that's, I don't know, add 1 + 1 or something like that. Just make sure that you can, in your test project, you can call something that's executed in your application code. And then start building on from that. And the larger the objects that you're testing, the more work it is to write the test. So look for small things in your code to start testing those. Once you've got the basics set up, then I don't think the goal is to get to 100% test coverage to test. That's even in commercial projects, that's always too expensive. So then you probably want to be thinking about what things are likely to go wrong, or if I had a bug report from somebody and I should have spotted that, or okay, fair point, but I'm not going to have time to keep testing that by hand. But I think I or a contributor could make the same mistake again, or similar mistake. Maybe that's another good place to start writing tests. So I hope that makes some kind of sense.
Yeah, I think it does. My other, I guess it's more of a discussion, maybe / suggestion. Since examples, I find examples, I completely agree with you that reading other people's examples is extremely useful. Maybe one thing that could be done is to add tests to the sample plugin template, which is what most people use to start. And this already also gives maybe an idea of how to initialize functions, or the classes, the settings, whatever it needs to be done.
That's brilliant. I was thinking of forking it, but that's to add a test example. But what you've just said is so obviously so much a better idea. Thank you very much.
glad this made sense. All right, let's see if there is. I think there is no other question in the chat. I only see a bit more comments about this code mirror testing in here. That the tip is basically they just imported code mirror itself, and that approach only works if you are testing the editor functionality itself. So thanks, Tim. Chris has one question.
Yes, I was just going to type it, but probably I can just speak it here. I was wondering, like the other most common method we kind of use, or at least the one I'm familiar with, to kind of check what's happening during development is like logging. Like you console log stuff, and when you pay attention to the console log, and when you don't, that's also like looking at the quote from of Koala, you don't have to run the command in Obsidian all the time. Like logging serves kind of a similar purpose to me, because it's like also ensuring that you don't have to switch to the actual end product all the time, but actually look during the development or earlier catch mistakes earlier already. And I was wondering, to me, it's somehow doing a lot of debugging logs and testing seem to have a similar purpose. So what's the difference? Is it like when to use what, or how do they complement each other?
That's really interesting point. So philosophically, logging feels a bit closer to me to debugging. The big thing about the test is you write the test, and then every time you run it, it's confirming that the behavior is unchanged. Whereas when you add log output, that's only any use if you're actually looking at it. So logging is really good for understanding code. And I've paired with developers who use it really proficiently because they understand enough about the Obsidian internals. They could, A.B.C. bang, that's magic information. But logging doesn't pay for itself in terms of preventing other people from making mistakes with your code, preventing you from making mistakes with your code. So I'm not saying don't log, but I'm saying yes, you'll get useful information with logging, but it's not the kind of testing that I'm really trying to advocate for in this talk.
If I can add something, I think the biggest difference between adding logs that you are using more effectively to debug is this is still a manual process. When you have really this type of tests frameworks, then you can also use automation, right? So you can push this, it gets executed in GitHub. You don't have to remember to have run all the tests and see if actually something failed. And also when you get contributions, since you can run this in this continuous integration process, you as the developer don't have to run the test when someone else adds stuff to your code. The other person also gets information about when things are broken, and you get information as well about maybe should I merge this already into my plugin if it's going to break things and so forth.
That's a really nice summary. I guess one thing I would add, the advantage that logging has over tests is logging can run on users' machines. So if you get some, other than on iOS and iPad, but so if you get some really obscure bug and that you can't track down and you can't reproduce, then adding a log there, and then if a user has the problem, asking them to send you the console output, that's something that testing is not going to be able to help you with because you couldn't reproduce the bug in the first place. So I think speaking up for logging, that's another important use case for it.
I don't see any raised hands nor any other questions in the chat. So then I will just would like to thank you very much again, Claire, for giving this really, really great talk. I think this is going to be very, very useful for a lot of the plugin developers, and really look forward to all the resources that you are going to share later on with us, and the discussions that might come out of this, maybe on a dedicated thread.
Brilliant, thank you. Thank you very much to everybody who came and to anyone who's watching it on YouTube later. And happy testing, and do let me know how you get on. I'd love to see what people are doing. Thanks a lot. Bye-bye.
Thank everyone. See you next time.